Hello and welcome everyone to the session. My name is Vibhati and in today's session we are going to start a very exciting series that is NEET 10, a game changer. Of course, it is a game changer for you because you can, if you follow this series for the next 10 days, you can score 650 plus. If you are at the score of 600 right now, you can reach up to 650 or more. If you are already scoring 650 in your mock test, you can go up to 700, right? So, hello everyone. Please keep your pen and copy ready for solving the question. Hello Yeri, hello Komal, hello Lokesh, hello Avinash. All right. So before starting the session, there's one important update for you. So we are starting this series for you, and in this series we'll be solving a lot of questions with you, and if you are facing any trouble in any concept, you can rectify your mistakes, you can clarify your concepts with the help of these questions. We are going to conduct 4 classes in a day. We are going to conduct 4 classes in a day. We'll be starting at 12 to 1, me, Vibhati, I'll be taking your physics class. Then 1:30 to 2:30, zoology class will be there with Tanya ma'am. Then 3 to 4, we will be having botany sessions for you with Beena ma'am. After that, 4:30 to 5:30, we'll be having chemistry class with Pawan Kasu sir. So, you can watch it live on YouTube. This is our channel. You can subscribe the channel so that you can get the notification. Yes, excited for this session? Yes. All right, guys. Along with this, we have one more update for you. We are starting Vedya 2025 batch for you. So, in order to get more information about this batch, you can fill in this Google form and the link is given in the description box. All right. Good afternoon, everyone. Good afternoon, guys. Okay, so let's start with the question number 1. The question number 1 is a solid sphere of uniform density and radius r applies a gravitational force of attraction equal to F1 on a particle placed at a distance 2r from the center of the sphere. So this is the center of the sphere, beta, and this is a particle of, let's say, mass m, and both are at a distance of 2r. Now this complete sphere, it exerts force F1 on this particle which is kept at a distance 2r. Now what we are doing is, we are making a cavity over here. This is a spherical cavity of radius r by 2 is now made in the sphere. So this remaining portion is applying a force of F2 on this particle m. Then what is the ratio of F2 to F1? What is the ratio of F2 to F1? Definitely you can get 180 in physics if you follow this series for the next 10 days. Alright, try this one everyone, try this one, come on bacho, try this one. We have a solid sphere, it is exerting force F1 on small m mass. Now we are making a cavity inside this sphere of radius r by 2, then the force exerted by the remaining part of the sphere is F2. Then what is the ratio of F2 to F1? Try this one. This question is from gravitation. Every year you can expect 1 question or 2 questions from the gravitation part. All right. So, if the complete sphere is there, let's say the mass of the sphere is capital M and the small m is placed at a distance 2r from the center of the sphere. Then what is the value of F1? G m1 m2 divided by r square. The separation is 2r whole square, which is 4r square, right? Now what we are doing? We are removing this much portion. If you remove this much portion of radius r by 2, then let's find out what is the effect of this much portion on small m. How much force is exerted by this portion that has been removed on small m? So over here, let's say this force is F dash. So for complete 4 by 3 pi r cube volume, the mass of the sphere is capital M. How much volume we are removing? 4 by 3 pi times r by 2 whole cube, which is 1 by 8 times the total volume. So this will be m by 8, right? We are removing 1/8 of the total volume. So basically we are removing 1/8 of the mass over here. So the mass of this removed portion is m by 8, and separation between the center of the removed portion and small m is 3r by 2. Because this is the center of the removed portion, you have to remove r by 2 from here. So this remaining distance will be 3r by 2, right? So over here remaining distance is 3r by 2. So force applied by the removed portion F dash is G m1 m2 divided by 3r by 2 whole square, which will be G mm into 8 divided by 8 into 9 r square by 4, which is G mm divided by 18 r square. Okay. So this is the new, this is the force exerted by the removed portion. So what will be the total force exerted by the remaining portion? So you can do it like this. Total force exerted by the complete portion minus total force exerted by the removed portion will give you what? The total force exerted by the remaining portion. That is how you can do it. So F1 is G mm divided by 4r square minus F dash is G mm divided by 18r square. That will be your F2. So you can take LCM as 36 r square. So this will be 9 GMM minus 2 GMM. So this will be 7 GMM divided by 36 r square. This is the value of F2. Now we have F1, we have F2. Can we find the ratio? Yes, we can find the ratio. F2 to F1. F2 will be 7 GMM divided by 36 r square and F1 is GMM divided by 4r square. R square cancel, GMM cancel, this will be 9. So ratio is 7:9. Ratio is 7:9, which is option D. I hope all of you guys are getting the same answer. Well done. All right. Now let's move on to the next question. The next question is, in the standard YDSE, the intensity on the screen at a point distant to 1.25 fringe width from the central maxima is. So if the slits are identical, we have to assume that the slits are identical. So over here, the value of y, the distance of the point P from the central maxima is value of y, right? So y is given as 1.25 times the fringe width. So what is the fringe width? It is nothing but 1.25 times lambda d upon d. Lambda d upon d is fringe width, so it is y is 1.25 times the lambda d upon d. Okay? Now over here, if you look at the path difference, so path difference is yd upon d. Path difference is yd upon d. Y is given this much. So let's find path difference delta x as 1.25 lambda d upon d into d upon capital D. Cancel, cancel, cancel. So we have path difference as 5 by 4 lambda. This is your path difference. 1.25 is nothing but 5 by 4 lambda. Over here, you can find the phase difference now. So phase difference is nothing but 2 pi by lambda into path difference, which is 5 lambda by 4. So it is 5 pi by 2. 5 pi by 2 is your phase difference. Okay? Is your phase difference. Yes, beta. Yes, Pramila. Yes, you can improve, beta, if you practice more and more questions. So this session is all about practicing questions, right? So we'll be practicing a lot of questions in every session so you can improve your score. Well done guys. Now this is the phase difference. What is the intensity? It is I max into cos square phi by 2. Phi is 5 pi by 2, so phi by 2 will be 5 pi by 4, which is pi plus pi by 4, which is pi plus pi by 4. So cos of pi plus pi by 4 is how much? What is cos of pi plus theta? It is minus cos theta. So it will be minus cos pi by 4, which is minus 1 by root 2, right? Now you have to put the value of cos square phi by 2 in this expression. So I will be I max into minus 1 by root 2 whole square, which will be I max divided by 2, which is option 1. Option 1 or option A is the correct answer. Well done guys. Good job everyone. Let's try the next question. Maximum kinetic energy. This is from photoelectric effect. This is from modern physics Pramila. The maximum kinetic energy of a photoelectron is E when the wavelength of the incident light is lambda. So when wavelength is lambda, maximum kinetic energy is E. Now energy becomes 4 times when the wavelength is reduced to 1/3. So energy is 4 times E when the wavelength is lambda by 3. Then what is the work function of the metal? So you can apply Einstein's photoelectric equation, right? So over here we have K max is equal to E minus phi naught, right? So in the first situation, E is the total energy. Let's say it is E dash minus phi naught. E is the energy of the photon. Radhika, please refresh it once. If you are facing any trouble with audio or video, please refresh the session. Alright, kinetic energy maximum is given as E and it is equal to hc upon lambda minus phi naught. Here, when the wavelength is lambda by 3, kinetic energy is 4E. So it will be 4E times hc upon lambda by 3 minus phi naught. So it will be 4E is equal to 3 hc upon lambda minus phi naught. Now let's multiply this equation 1 by 4. If you multiply this by 4, you will get 4E is equal to 4 hc upon lambda minus 4 phi naught, right? And this one will be 4E is equal to 3 hc upon lambda minus phi naught. Now what you can do, you can subtract equation 1 with equation 2. So you will get 4E minus 4E 0 is equal to 4 hc upon lambda minus 3 hc upon lambda is hc upon lambda minus 4 phi naught, minus of minus phi naught is plus minus 3 phi naught. So over here 3 phi naught will be hc upon lambda and phi naught will be hc upon 3 lambda. So work function will be option B. Work function is option B. It is hc upon 3 lambda. So this types of questions you will be getting in NEET exam beta. This equation is very important for us. Kinetic energy maximum is equal to energy of the photon minus work function. Okay, please remember it. Alright, next is this one. This is from laws of motion. Two blocks are in contact on a frictionless table. One has mass m and other one has mass 2m. A force F is applied on 2m as shown in the figure. Now what we are doing? We are applying the same force from the right on small m. In the second situation, we are applying the same force but on small m, not on 2m. Okay, hello beta. In the two cases, the ratio of force of contact between the two blocks will be. So in these two cases, first and second, you have to find the ratio of normal reaction in these two, between these two blocks. Okay, so try this one, come on guys. This is from laws of motion. You will be getting 1 or 2 questions from laws of motion in NEET exam, and the questions will be direct questions, either conceptual question or they will be based on the formulas. Fine. So in this, both of these two cases, what is the total mass of the system? Can you tell me, guys, what is the total mass of the system in both of these two cases? Radhika, Sunita, Varshini, Pramila, Vimochana, Rupa, Komal, anyone? What is the total mass of this entire system? Come on guys, I'm waiting for your response. All right, it is m plus 2m, that is equal to 3m, right? Now what is the acceleration of the system? It is net external force divided by total mass of the system. So what is net external force in both of these cases? F, right? Yes, well done. F divided by total mass is 2m plus m, that is 3m. So both of this system will accelerate with F upon 3m only. But acceleration of this will be in this direction and acceleration of this will be in this direction, right? Now in this situation, if you look at small m, so if you draw the FBD of small m, mg will be down, normal reaction provided by the ground will be up, and normal reaction provided by this 2m will be towards right. Okay. Now acceleration of the block is F upon 3m. So for this small m, the net force in the direction of acceleration is normal reaction between 2m and m, which is R2, which is equal to ma. So it is m into F upon 3m, which is F by 3. In the second situation, if you look at this 2m block, so this 2m block is accelerating towards left, 2mg down, normal reaction provided by ground up, and normal reaction provided by small m is towards left. Okay, is towards left. So it is R2 dash. So R2 dash in this case is in the direction of acceleration for 2m, right? So over here R2 dash will be 2ma, where a is F upon 3m. So R2 dash will be 2ma is F upon 3m, which is 2f by 3. So over here, if you take the ratio of R2 to R2 dash, R2 is f by 3 and R2 dash is 2f by 3. So it will be 1:2. So correct answer is option B, which is 1:2. Okay? Yes. This session is the mixture of some new questions and some PYQs. So you will be getting PYQs, don't worry. All right. Next is this one. This is from conservation of energy, that is from work, energy and power. A toy gun uses a spring of a very large value of force constant K. When charged before being triggered in the upward direction, the spring is compressed by small amount x. If the mass of shot is m, it will go up to a height of, so it will, see, we are compressing the spring and then we are releasing it. We are compressing the spring and we are releasing it. So once you release the spring, what will happen? It will transfer its potential energy, the elastic potential energy, to this mass. With the help of that elastic potential energy, what will happen? The mass will gain kinetic energy, and with the help of that kinetic energy, the mass will go up, right? It will go up, but since it is going against gravity, so what will happen? It will go up to a certain height and then it will fall back, right? So you have to find how much height it will gain before coming down, right? So it is very simple. Why it is going up? Because we are providing it certain energy. Where that energy is coming from? From the spring. So spring is providing half kx square energy, and with the help of this energy, it is going up to a h height. It is going up to a h height, right? So with the help of this spring elastic energy, it is gaining potential energy. So spring is transferring its energy to the ball, and ball is going up and gaining potential energy, gravitational potential energy, mgh. So basically half kx square is converting into mgh. So h will be kx square upon 2 mg. So this is the height gained by the ball. kx square upon 2 mg. See, the solution is very small. ठीक है? All right. ठीक है, I'll try to decode the questions for you along with the formula and chapter name. Rupa, don't worry. After 2 to 3 classes, you will be able to decode on your own. ठीक है? Hello RC. All right. चलिए. Now, let's move on to the next one. If linear charge density of a wire is shown in the figure over here is lambda, then electric field at the center of the wire will be. So this wire is in the form of circular ring and we have to find the electric field at the center. Okay? At the center of this ring over here. So what will be the electric field at the center of this ring? Anyone? Anyone? Hello Ashish. Anyone बच्चों? This can be done without lifting the pen. I'm waiting for your response. Option B. Okay. According to you, this should be the answer. Well done, Varshini. Anyone else? Option A? Okay. All right. ठीक है. All right. Look at this situation over here. Just forget about this one. We have two charges, Q and Q over here. At this point, which is the midpoint, what will be the net electric field at the midpoint? So because of this Q, it will be away from it and it is KQ divided by R square. And because of this Q, it will be away from it and it will be KQ divided by R square. So these are two equal and opposite fields, right? These are two equal and opposite fields. So what will happen? This two will cancel one another. This two will cancel one another. Okay? So net electric field at this point will be 0. Fine? Now look at this ring. If you consider this segment and it has charge small q, then it will create some electric field E over here, and just opposite to this segment we have similar charge q over here. So what will happen? It will also create the same amount of electric field in the opposite direction. So these two equal and opposite fields will cancel each other. Same for this one. ये जो whatever electric field is created by this portion, this will be cancelled by exact opposite segment. For this, this will cancel. For this, this will cancel. For this will cancel. So what is the net electric field at the center? 0. Right? Well done. Well done. So correct answer is option D, none of the above. This is completely conceptual question. You might get scared by looking at the options, but no need to get scared. Okay? All right. Chaliye. Now next is this one, again from the electrostatics. The electric potential at any point xyz in meters is given by V is equal to 3x square. The electric field at point P 2, 0, 1 is. All right, you have to find the electric field. Electric potential is given. How do we find electric field? It is minus of dV upon dx. Can you find it, guys? Can you find it? From electrostatics, you will get at least 2 questions in NEET exam, and questions will be like this only. Very easy questions you will be getting in NEET exam. Okay, so you just have to focus on your basic concepts. All right, you have to focus on this negative sign as well. Good try, Radhika. You have to focus on this negative sign as well. Do not forget this negative sign. This is where most of us make the mistake. Yes, E is equal to minus dV upon dx over here. So it will be minus of differentiation of 3x square. So it is 3 times the differentiation of x square is 2x, which is minus 6x. Now you just have to put the value of x from this given point coordinates, right? So value of x is 2, so it will be minus 6 into 2, which is minus 12 volt per meter. So correct answer is option D. Well done, well done. Okay, let's move on to the next one. The current drawn from the battery shown in the figure is, this is the diagram. We have to find the total current drawn from the battery by this circuit over here. Give it a try. Give it a try, guys. Find the effective resistance of the circuit and then apply Ohm's law. Try to find the equivalent resistance and then apply Ohm's law. Option B, well done. Okay. Option B, well done. Option B, well done, good job everyone. See, it's all about basic concepts. All right, well done bachcho. See, this will not draw any current, okay. So this is, will not consider this one in the calculation of R equivalent. This two are in series, the current will flow like this. This two are in series, so R equivalent will be R plus R, which is equal to 2R. So current in the circuit is V upon R equivalent, which is V upon 2R. So correct answer is option B. Well done. Okay, let's move on to the next one. AB is a wire of uniform resistance. The galvanometer shows no current when the length AC is equal to 20 centimeter and CB is equal to 80 centimeter. The resistance R is equal to, this is from current electricity, this is the question from meter bridge. So R and 80 are the resistances and this are balanced at the length of 20 centimeter and 80 centimeter of CB, right? C is the null point, AC is 20 and CB is 80 centimeter and galvanometer is showing no deflection, that means it is not drawing any current from the circuit, fine. So over here, when this is balanced, if this is R, this is S, then you can apply the condition of balanced Wheatstone bridge, R upon S should be equal to AC upon CB. Using this, try to find the unknown resistance R. We have option C. Well done, well done. All right. Anyone else? We have option C from Radhika and Varshini. Well done, bachcho. Okay, R divided by S is 80, AC is 20 and CB is 80. So from this one 80 cancelled, so R will be 20 ohms. R will be 20 ohms. Good job everyone, good job. Yes, option C is the correct answer. Okay. Next is this one. A circular curve of a highway is designed for traffic moving at 72 km/h. If the radius of the curved path is 100 meter, the correct angle of banking of the road should be, you have to find the correct angle of banking. So if angle of banking is theta, then tan theta is equal to V square upon RC. Apply this concept, remember this formula directly for the banking of the road. This is from circular motion. Try this one everyone. Convert 72 km/h into meter per second first and then use this value in the formula. This is from circular motion. You might get one question from this chapter. Option C, well done, well done. Anyone? V will be, see it is 72. So it is 72 into 5 upon 18 meter per second. So it will be 20 meter per second, right? So you have to put the value of velocity as 20, not as 72, okay? So it will be 20 into 20 divided by R. R is 100 into G is 10. So see 0, 0, 0, 0. Then this is 5, so it is 2 upon 5. So tan theta is 2 upon 5. So theta is tan inverse 2 upon 5, which is option A. No worries, beta. Option A is the correct answer. Now, since you were not aware of this concept, you can note it down separately so that in future, whenever you get questions like this, you can apply this concept directly, beta. This is from circular motion. Okay? Those who were not aware, please note it down separately. Okay? All right. Next is this one. An infinitely long conductor is bent into a circle. This is infinitely long conductor. Current is flowing like this. Somewhere it is bent in the form of circle like this, and then again it is going up to infinity. And I current is flowing into the conductor. Okay? R is the radius of the loop. Over here, we have to find the total magnetic field at the center of the loop. Try this one. Yes, Komal. We'll be including the questions of practical physics as well. Okay? Chaliye. Try this one everyone. Try this one, bacho. If you find something that is new for you, please note it down separately. Okay? If you feel that you are not able to remember this formula, note it down separately. You will find a lot of shortcuts during the session, so you can keep a small notebook for the shortcuts and the formulas. Okay? It is option C. Well done. See, it can be considered as two different figures, right? One is circular wire and other one is completely long infinite wire. So magnetic field at a distance r from infinitely long wire will be what? It will be, see, current is going like this. You have to stretch your thumb in the direction of current, align your fingers towards the center and curl. The curl is out of the plane. So magnetic field due to this infinitely long wire is out of the plane over here, and it is equal to mu naught I divided by 2 pi r, and it is out of the plane. For this circular wire, you have to again use right hand rule. So align your thumb in the direction of current, stretch your fingers towards the center and curl. The direction of curl is out of the plane. So magnetic field at the center of this circular wire, circular coil, will be mu naught I divided by 2r, and it is still out of the plane. So both of these magnetic fields are parallel. You can add this two to get the total magnetic field. Okay. So total magnetic field will be B1 plus B2, which is mu naught I divided by 2 pi r plus mu naught I divided by 2r. You can take mu naught I divided by 2 pi r common, and it will be pi plus 1. But none of the options are matching with this one. So look at this one. In numerator we have 2 and in denominator we have 4. So multiply and divide by 2. You will get option A. Okay? You will get option A. Fine? Alright. So over here you might find your answer. The learning from this question is you will get your answer correct. But sometimes options can be deceiving, right? You will feel, okay, my option is not given in the, my answer is not given in the options and none of the options are correct. So let's leave it. but make sure that you double check your options. Fine, options can be deceiving as well. Fine, so this is option number A. Well done, guys. Next is this one. This is very famous concept. This is from Magnetism and Matter, and if you get question, then you will get questions based on these concepts. Okay. The relative permeability is represented by mu r and susceptibility is denoted by chi for a magnetic substance. Then for a paramagnetic substance, which of the following options are correct? This is completely information based question. If you remember, then you can mark it correctly. Any idea what should be the correct answer? Any idea? Option C. Relative permeability is equal to 1 plus chi. Right? For a paramagnetic substance, mu r is greater than 1. Mu r is more than 1. So, chi will be mu r minus 1. So, it will be more than 0. So, it is option D, beta. You should remember this thing. You should remember this thing. For paramagnetic substance, mu r is more than 1 and chi is more than 0. For ferromagnetic substances, mu r is much greater than 1 and chi is much greater than 0. Okay? Please remember this one. Please remember this one. Alright, next is this one. Two bodies M and N of equal masses are suspended from two separate massless springs of swing constants K1 and K2 respectively. If the two bodies oscillate vertically such that their maximum velocities are equal, then the ratio of the amplitude of vibration of M to N is. Now this is from SHM beta. Okay. Now in SHM there are two important formulas. There are 50-50 chances that you get questions like this in SHM in NEET upcoming exam. So maximum velocity is A omega and maximum acceleration is omega square A. These are the magnitudes. Please remember these two correctly. Okay, please remember these two formulas. This will help you a lot in solving a lot of questions. Alright, so where we have two bodies, these are of equal masses and they are connected by two separate massless springs of spring constant K1 and K2. Now they oscillate vertically such that maximum velocities of these two bodies are equal. That means A1 omega 1 for first body should be equal to A2 omega 2. Then what is the ratio of the amplitude of M to N? So A1 upon A2 will be omega 2 divided by omega 1. This should be the ratio. But the answer is given in terms of K1 and K2. So what you can do? You can use this one. Omega is under root of K by M. Okay. Omega is under root of K by M. So if you put it here, omega 2 will be under root of K2 by M and omega 1 will be under root of K1 by M. MM cancel, so we have under root of K2 upon K1. This is the value of A1 to A2. This is the value of A1 to A2, which is option D. Well done, guys. Well done. Please remember these two things. These are important for us in SHM. Okay? Alright. Next is this one. A small ball falling under gravity in a viscous medium experiences a drag force which is proportional to the speed. Then the terminal speed of ball within the viscous medium is, it is from fluid. Okay, mechanical properties of fluid. So it is going down, mg force is acting downwards, Ku, the viscous drag is going, it is acting up, but along with these two forces there will be one more force. Can you guess what force is this? Option D, option B? Can you tell me? Apart from these two forces, there is third force which is acting on the body. Can you tell me? No, this is viscous drag. That's already there. This is gravitation. Anything which is better for the question might not be better for the marks. Looks can be deceiving, guys. Can you tell me? This is going inside a viscous medium. Point force, yes. Upthrust will be there. So upthrust is, let's say, F. When the ball achieves terminal velocity, its acceleration is 0. That means the upward forces, they balance the downward force. Okay? So F plus Ku should balance mg. So from this one, Ku should be mg minus F and U should be mg minus F divided by K. So this should be the terminal velocity, which is none of this, Now, देखो, they are mentioning drag, viscous drag and gravity directly, but they are not mentioning this particular buoyant force over here. So you have to read your question carefully. These are the points where you can make the mistake. Okay, read your question carefully, beta, and consider all the possibilities. All right, next is this one. Two conducting circular loops of radii r1 and r2 are placed in the same plane with their centers coinciding. If r1 is much greater than r2, then the mutual inductance M between them will be directly proportional to. So mutual inductance of two concentric coins having smaller radius r1, bigger r2 is given as mu naught n1 n2 pi r1 square divided by 2r2. If you can remember these formulas directly, you will be able to give the correct answer within 10 seconds. Yes, well done. So you can see that it is directly proportional to r1 square divided by r2. So correct answer is option C. It is directly proportional to. Oh, no. We interchanged r1 and r2. Just a second, beta, just a second. We interchanged r1 and r2. It should be D. Just a second. R1 is the bigger radius as per the question and R2 is the smaller radius. So it will be pi R2 square divided by 2R1. So it will be directly proportional to R2 square divided by R1, which is option D. Okay? That's how it can be done. Okay, please remember this formula directly. R1 is the bigger radius, R2 is the smaller radius. Alright, next is this one. At what temperature is the root mean square velocity of the gaseous hydrogen molecules equal to that of hydrogen molecules at 47 degrees Celsius? You have to find the temperature at which RMS speed of hydrogen molecule is equal to the oxygen molecule at 47 degrees Celsius. Try this one, come on guys. Okay, Rupa, we'll try to arrange the sessions. We'll try to include more and more questions from modern physics. Hello, Vita. Okay, try this one. RMS speed. What is RMS speed? This is from kinetic theory of gases. Vrms is equal to under root of 3 RT divided by M. We put temperature in Kelvin. The only thing that you need to take care of is of temperature. We don't put temperature directly in degrees Celsius. Do not make this mistake in any question. Try this one, come on guys. So 47 degrees Celsius will be 47 plus 273, which is 320 Kelvin. Now RMS speed of hydrogen and oxygen molecule should be same. So Vrms of hydrogen is under root of 3 R, temperature for hydrogen divided by M for hydrogen is 2, is equal to 3 R, temperature for oxygen is given as 320 divided by M for oxygen is 32. So if you cancel this one, this will be 10, square on both the sides. So we have 3 RT for hydrogen divided by 2 is equal to 30 R. So RR cancel, so we have temperature for hydrogen as 60 divided by 3, that is 20 Kelvin. So 20 Kelvin is the correct answer, which is option A. Yes, A is the correct answer. No beta, this is same for all. Okay. Chaliye, let's try this one. This is from alternating current. In the circuit shown below, what will be the reading of the voltmeter and ammeter? Voltmeter, ammeter ka reading kya hoga for this circuit? So you can see that VL is equal to VR. If VL is equal to VR, then the circuit is in resonance. The circuit is in resonance condition, right? So VR is equal to V over here, which is 220 volts, right? And the reading of ammeter and voltmeter are the RMS value. So this is RMS value given, which is 220. Okay, 220. So 220 divided by, what is the net current in the circuit during the resonance condition? I is equal to V upon R. So IRMS will be V RMS divided by R, which is 220 divided by R is 100. So it will be 2.2 ampere. So correct answer is option D. Correct answer is option D. Okay? Alright. Chaliye. Now, let's move on to the next one. Okay. This is from optics. The graph shows how the inverse of magnification produced by a convex thin lens with a variation in object distance u. What was the focal length of the lens used? What was the focal length of the lens used? Chaliye, try this one, come on guys. Those who do not remember the formulas of kinetic theory of gases, please revise the formulas and then try to attempt the question. Don't spread misinformation. Chaliye. See, this is a straight line. Okay. How do we write the magnification of the lens? F upon F plus U. This is in terms of focal length and object distance U over here. Okay. Now, if you take the inverse of M, 1 upon M will be F plus U divided by F. So it is F upon F plus U by F. So 1 upon M is 1 plus U by F. Right. So we get this relation between 1 upon M and U. 1 upon M is equal to U times 1 by F plus 1. Alright, it is U times 1 by F plus 1. Okay. Now you compare it with Y is equal to Mx plus C. On Y-axis we have 1 upon M, on X-axis we have U. So the slope of the line is equal to 1 upon focal length. The slope of the line is equal to 1 upon focal length, right? So slope of this straight line is equal to 1 upon focal length. What is the slope? Tan of theta. This is theta. So tan of this theta is equal to slope. Okay. Now over here, if you find the tan theta, it is perpendicular divided by base. Perpendicular divided by base. So perpendicular is B, base is C. So 1 upon focal length is B upon C. So in this one, focal length is C upon B. Focal length is C upon B, which is option D. So correct answer is option D. This is the classic example of mixture of basic mathematics and optics. Okay. So whenever we have straight line, compare it with Y is equal to Mx plus C. Try to identify the slope. Equate the slope with tan theta. Using the graph, try to find the tan theta and you will find the focal length. Okay, you will find the focal length. Alright, chaliye. Next is this one, the nuclear reaction. This is from nuclear physics, modern physics. A nuclear reaction along with the masses of the particle taking part in it as follows. So, A plus B will give you C plus D plus some Q value. This is the nuclear reaction. you have to find the energy Q liberated in the reaction is. Chaliye, try this one, try this one. If delta M is the mass lost in AMU during the nuclear reaction, then energy liberated is delta M into 931.5 mega electron volt. Come on guys, this is one of the easiest question. Chaliye, try this one, try this one. This is one of the easiest question from nuclear physics. Now we don't have radioactivity, so you might get questions based on nuclear reactions and nuclear energies. Option D, well done. Option D, well done. Alright, so look at the product's masses. It is 1.001 plus 1.003. So it is 2.004 AMU. What are the reactants masses? This plus this. So it is 2.006 AMU. It is 2.006 AMU. Right? So when the nuclear reaction is happening, the mass is lost. How much mass is lost? Earlier we had 2.006, now we have 2.004. So what is the mass lost? 2.006 minus 2.004, which is 0.002 AMU. Right? So for 0.002 AMU mass lost, what will be the energy released? Delta M times 931.5 mega electron volt, which will be 1.863 mega electron volt. Okay? So that is how you can do it. Chaliye. Now next is this one. This is from semiconductor. Every year you will get at least one question based on semiconductor. Right? This is one of the PYQ. For the given combination of gates, if the logic states of inputs A, B and C are 0, 0, 0 and 1, 1, 0, then logic states of the outputs are, you have to find the output D in two cases. When A, B and C are 0, then what will be the output? And when A, B are 1 and C is equal to 0, then what will be the output? So this is your OR gate and this is your NAND gate. So over here for OR gate, output will be A plus B, which is equal to 0 plus 0, which is 0. Output of OR gate is input, one of the input of this NAND gate, and C is direct input to the NAND gate. Now for NAND gate, it is, let's say this is X and this is Y. So for NAND gate, the output is X into Y bar. So it will be 0 into 0 bar, so 0 bar is equal to 1. So when all three are 0, the output will be 1. So either C or D are correct. Fine. Either C or D are correct. Alright. Now over here, in the second case, we are keeping A and B as 1 and C as 0. So when A and B both are 1, then over here, the output of this OR gate will be 1 plus 1, which is 1. Now this one output is going as input for this NAND gate and C is another input for this NAND gate, which is equal to 0. So now for this NAND gate, inputs are 1 and 0. So output will be 1 into 0 bar, which is 0 bar, which is equal to 1. So for second case as well, the output is 1. So correct answer is option D. Correct answer is option D. Fine? Alright. Next is, this is again from semiconductor. The diode shown in the circuit is a silicon diode. The potential difference between A and B will be. Now this is P type and this is N type. This is positive terminal, this is negative terminal. Can you tell me in what biasing this diode is connected? Is it reverse biased or forward biased? The diode is connected in what biasing? Reverse or forward? Come on guys. Yes, N type is connected to the higher potential and P type is towards the lower potential. So this is reverse biasing. It will offer infinite resistance. So the circuit will open like this. Ideally, it will offer infinite resistance. It will not allow any current to pass through it. Okay. So over here, there will be no current. So potential difference across point A and B is equal to 6 volts only, which is option A. Well done, guys. Well done. All right. Okay. Next is this one. In semiconductors at room temperature, the valence band is partially empty and conduction band is partially filled. Valence band is completely filled and conduction band is partially filled. Valence band is completely filled and conduction band is completely empty. What will happen to the semiconductor at room temperature? Come on, guys. This is like one of the very important lines from NCERT. Come on, guys, focus on the questions over here. We have very few questions left. Option A, all right. Chaliye, बहुत ही बढ़िया, excellent. In semiconductor at absolute zero temperature, the valence band is completely filled and conduction band is completely empty. This is at absolute zero temperature. But at room temperature, conduction band is partially filled and valence band is partially empty. Some of the electrons, they jump from valence to conduction band, right? So correct answer is option A. This is one of the important concept of semiconductor. Correct answer is option A. Well done, guys. Good job, everyone. Good job. Okay. Now, next one is two blocks of masses 10 and 30 kilogram are placed along a vertical line. The first block is raised through a height of 7 centimeter. By what distance should the second mass be moved to raise the center of mass by 1 centimeter? So we are keeping 10 and 30 like this. Now what we are doing is, we are raising 10 kilogram by a height of 7 centimeter. Then by what distance 30 kilograms should be displaced so that center of mass is raised by 1 centimeter. So delta YCM can be written as M1 delta Y1 plus M2 delta Y2 divided by M1 plus M2. What is the change in center of mass for this one? 1. M1 is 10. What is the displacement in 10? 7. M2 is 30 into delta Y2 divided by M1 plus M2 is 40. So we have 40 is equal to 70 plus 30 delta Y2. So we have minus 30 is equal to 30 delta Y2. So delta Y2 will be minus 1 centimeter over here. Minus sign shows that instead of moving it up, we should move it downwards. We are taking positive for upward direction and we are getting answer as negative. That means instead of moving it up, we should move it downward. The 30 kilogram should move downward by 1 centimeter to raise the center of mass by 1 centimeter. Well done, guys. Good job, everyone. Good job. All right. Look at this one. This is the question from modern physics again. This is from atoms. If the radius of the first Bohr orbit is x, then de Broglie wavelength of the electron in the third orbit is nearly. So radius of the first Bohr orbit is x. And for third orbit, r is directly proportional to n square. So for third orbit, n will be 3. So r3 will be 3 square times r1, right? It will be 3 square times r1 over here, which is 9r1, which is equal to 9x. Now we know that mvr is equal to nh upon 2 pi. So from this one, mv, r is 9x for the third orbit, is equal to nh upon 2 pi. So mv, the momentum of the electron is nh upon 18 pi x. n is equal to 3, so it will be 3h upon 18 pi x, that is equal to mv. Now de Broglie wavelength is h upon p, which is h upon mv. So you just have to put the value of mv from this. So it is h upon m is 3h 18 pi x. H cancels, so this is 6 pi x. So correct answer is option B. This is the de Broglie wavelength. Option B is the correct answer. Good job everyone. Alright, so this is another very good question from modern physics. Next is this one. This is from rotational motion. 4 particles each of mass m are placed at the corners of a side of square of length L. Like this. The radius of gyration of the system about an axis perpendicular to the square and passing through the center is. So this is the axis of rotation we are considering. So we have to find the radius of gyration of this system about this axis. So let's find the moment of inertia of this complete system about this axis. So this complete is diagonal, which is L root 2. So half of the diagonal will be what? L root 2 divided by 2, which is L by root 2. So each mass over here is at a distance of L by root 2 from the axis of rotation. Fine. So total moment of inertia of this mass is ml by root 2 ka whole square. For this as well, ml by root 2 whole square. For this as well, ml by root 2 whole square. For this as well, ml by root 2 whole square. So total moment of inertia is 4 times the moment of inertia of single mass, which is 4 ml square by 2, which is 2 ml square. Now for finding the radius of gyration, we have to equate moment of inertia with mk square. Moment of inertia is 2 ml square. Total mass of the system is m plus m plus m plus m, 4m, right? So it will be 4m into k square. So it is L square by 2 as k square, and k will be L upon root 2. So correct answer is option A. K will be L upon root 2. Fine. So that is how it can be done. So that is it for today's session everyone. Thank you so much for your participation. But before you go, guys, we have a wonderful news for you. We are launching Vedhya 2025 batch for you, and this batch will give you more confidence for your NEET 2025 preparation. So if you want to be a part of this ultimate NEET long-term course, you can fill the Google form and the link is given in the description box. Now what are the special features of this batch? So we'll focus more on physics and chemistry for you. We know all of you guys love physics and chemistry, so we'll keep special focus on these two subjects. We'll focus on critical chapters. We'll provide you a lot of shortcuts and correct technique to apply formulas for the critical chapters as well. We'll be practicing more than 20,000 questions in this batch. We'll be having 30 weekend tests and 15 grand tests. So these are the special features of this batch. If you can follow all these things, you can definitely get 700 plus in NEET 2025 and 2026 exams, right? So yeah, please fill the Google form. Link is given in the description box. So please do that. You will get the call from our team for the further updates. Okay? All right. So if you like the session, please like, comment, share the session with your friends, subscribe to the channel, press the bell icon so that you will get the notification for the upcoming classes as well. Okay? Upcoming classes as well. So Varshini, once you fill the Google form over here, you will get the update from the counselor. Okay? All right. Thank you so much, everyone. Thank you so much, guys. Yes. So if you join this batch, definitely you will fall in love with physics and chemistry as well. Okay. So that is it for today's session, everyone. I'll see you tomorrow at 12 to 1 with 25 more amazing concepts and questions. So take care everyone. Bye bye bachcho. All the best. Don't go anywhere. We have one more class at 1:30, then zoology, botany and chemistry. So take your break and then come back to the session for zoology. Take care bachcho. Bye bye. Bye everyone.